Alrighty, you guys, we're going to look at modeling and solving more two-step equations today. So our process is going to be the same, and actually I highlighted the process kind of right down here when we're going to solve this first one algebraically. The first step is to get the variable term by itself. So this is kind of the piece with x in it. And then the second step is to get the variable by itself. So if we're using x, this is just x, right? To get x all by itself. So that's going to be our process today. Nothing's changed there. We've just got some different situations we're going to look at. This first one is a word problem. There's kind of this scenario here where we're talking about the elevation of Kumantuk. I don't know how to say that, but we'll just call it Q-Town. Q-Town and Nunavut is 1 meter less than half the elevation of Prince Rupert, British Columbia. And then it goes on to say, if the elevation of Kumantuk, Q-Town, is 18 meters, what is the elevation of Prince Rupert? So we got this piece here. This is 18 meters. Oh, no, that's the Rupert piece. Hang on. This is our unknown. It doesn't say anything about the elevation of Rupert. It compares it to Q-Town, but we don't know the elevation of Prince Rupert. Here's that Q-Town, and it's 18 meters. So there's some reasoning we have to apply here, and I've found, as I work through problems like this again and again with students, I found the best way to do it is to kind of set up or write down what we know about this Q-Town. So we know that Q-Town is at 18 meters. Right? That's this sentence here. It tells us that about Q-Town. It's 18 meters. We also know that Q is this, 1 meter less than half the elevation of Rupert. Maybe we'll come back to that. We know that, because it's important to acknowledge here that Rupert is unknown. And actually, sorry, it's Prince Rupert. So we're going to call that P, and that's what they did in the question here. That's why we're calling it Prince Rupert. We're going to use the variable P. So we know that Q-Town is 18 meters. We know that Prince Rupert is unknown so far. We're going to find that out. We also know that Q is 1 meter less than half the elevation of Prince Rupert. So it's equal to half of P minus 1. Right? They said in words it's 1 less than half P. So the important thing is that we understand that we've got these two pieces of information about Q. And I said it is 18. We could also say it's equal to 18. So we know that Q is equal to these two things. So there's I believe it's a transitive property of equality tells us that if Q is equal to 18 and Q is also equal to 1/2 P minus 1, then those two things are equal. The two highlighted pieces are equal. So 18 is equal to 1/2 of P minus 1. Alright, this is how they get the equation they're going to use. Whoops. This is how they get the equation they're going to use here, is that 1/2 of P minus 1. And you can write that 1/2 of P a few ways. You can write it as 1/2 times P over 1, which is what they did. That's how we get P over 2. You can also write it as P divided by 2, right? When we're halving it, we're dividing it by 2. So I just wanted to get you to here. I want to make sure you understand where that's coming from. Then they also built the model, and we're going to solve both of these. So on the left down here on the bottom, I'm going to redraw this model, and then we're going to solve it. So go ahead and redraw that model. Alright, here's what they drew up top. We have this piece here, this half of P, and you see they kind of broke it in half and kind of shaded in one side. We have a minus 1 tile, and then we have 18 red filled in plus 1 tiles. So half of P minus 1 equals 18 is what we're looking at in the model. Now the way to model a solution is that we want a whole P. We want to get to this. So we got to get that by itself, right? So our first step is to get rid of this negative P. And in that case, we're making a zero pair because we're getting rid of it. So we're adding a 1 to both sides, on the left and the right, so we can get rid of this piece. That's our first step. Our second step is to get a whole P on the left. So we need 2 of these we need 2 of this half a p, so which means we need 2 of all of this stuff. So we'll draw that in on the right. That's going to be our solution on the right. Alright, just putting the finishing touches here on doubling this side, because we doubled this side, right? So now we have a whole p is equal to 39, right? And we're talking about meters here because we're talking about the elevation of Prince Rupert. P is equal to 39. Our 2 steps, first that we got rid of this, so we undid that operation. We got rid of the -1 by adding +1, and then we had to do this as well, right? We used opposite operations to get rid of the -1. And then our second step, maybe I'll mark that up in black here, was to take that half a p and times it by 2 to get p by itself. So algebraically here, we'll show exactly what that could look like. And I'm going to write it the other way just because we could go either way, and this is the way I built my equation up at the top. So the first step here with our equation algebraically is to add 1 so we can cancel that 1. If we add 1 to the right, we have to add 1 to the left, which makes 19. And now I'm going to rewrite what I have. I have 19, and it's now equal to 1/2 of p. So my second step is going to be to multiply both of these by 2. I want to get rid of that half by timesing by 2. So I'm going to do that on both sides. And again, we could think of that, it was p divided by 2, so that's why we're timesing by 2 to cancel. It was p over 2, so we're timesing by 2 to cancel those p's. Or it was half a p, so we're timesing by 2 to cancel a half. Either way, we got to undo that operation. We got to undo that timesing by a half, and we do that by multiplying by 2. Or you could multiply by 2 over 1 if you like, and you'll see that it cancels out and you get p by itself. When we multiply 19 by 2, we get 38. I'm sorry, I said this was 39 over here. It's 38, isn't it? 38 equals p. So those are our 2 steps. When again on the right now, first we undo the -1 by adding 1, and second we undo the p over 2 by timesing by 2. Alright? Now that we've seen our answers here, I suggest you always finish with a sentence so we know what that means. We double check that we've got the right thing there, right? The elevation of Prince Rupert is 38 meters. And you could verify, and we'll get to that on the back, I believe, where you actually go a step further here. That's going to tell us to verify it. So 2 more questions we're going to look at right here. Same 2 steps every time, right? Step 1 is to get this x term by itself. So in this case, we do that by getting rid of the 6. It's a -6 right now. The opposite operation is to add 6. So we make 0 on that side. If we add 6 on the left, we have to add 6 on the right. Now we've got 10. That was our step 1. Undo -6 by adding 6 to both sides. And if you're still not sure about steps, write that down for yourself. Know that that's what's happening. Now we've got this. Now we've got -x over 12 is equal to 10. Because our 6 is gone, our 4 is gone, and we made it into 10, and we still have that piece. And we've written out what we have left, and now we've got to figure out how to get x by itself. That's our second step. Right now it's being divided by 12, so we're going to multiply by 12. We're going to undo the divided by 12 by multiplying by 12. If we do that on the left, we have to do that on the right. So our step 2 is to undo divided by 12 by times by 12. Now this cancels. We've got -x left, and it's equal to 120. But we're actually not done at this point. What we want to know is what positive x is equal to. So you might see right away that we're flipping the left, we're going to flip the right. Or if it helps to think about, you can tell yourself that you're going to times them both by -1. And now the negatives cancel over here. We're left with x, and we're left with a negative 120 on the right. Now this question also says verify. So we're done the solution step. The verification looks like this, and this is a great tool. This is a great strategy for all these questions, really, just to make sure you're doing these questions properly. Here's what we started with. I just rewrote this question right over here. We started with that, and now our solution was that we think x is equal to -120. So the question actually says negative x over 12. So I'm gonna get rid of that x, and I'm gonna put in my negative 120, because that's what x is. So now I'm subtracting a negative, I've got a positive. You could have worked with this in this case. You could have worked with the negative x equals 120 and just put that on the top because it asks for a negative x. But it's best just to describe our answer as a positive x, so you know. Back over here now, we've got 120 divided by 12, so that is 10. 10 minus 6 equals 4. Yes, it checks. We get the right answer, and our signs are all good, so we know we did our math right. Right? We know this is correct. Again, pause, write down the two sides, write down the steps. Make sure you understand the steps, you guys, before you move on to the last example. You need to know what's going on. You need to be able to explain to yourself what's going on here and have some notes that make it understandable. All right? Last question here. Same two steps. I'll write them down as we go. First, we want to get the k term by itself, that whole k over 7 piece. We've got a positive 3 there, so we're going to take away the 3 to get rid of it. If we take away the 3 on the right, we have to take away the 3 on the left. So negative 4 minus 3, we can think of that like negative 4 plus negative 3 equals negative 7. So our first step was to undo the positive 3, or undo the 3 that was there by taking away 3. And we did that on both sides. We always do that. Whatever we do to one side, we have to do to the other side in these equations, in every equation. Now we've got this. Negative 7 equals k over 7. So we've got to undo that divided by 7. We're going to change the color. We're going to times by 7. So that cancels. And now we've got negative 49 equals k. So our second step was to undo the divided by 7, right? This right here. We're on by times by 7 on both sides. Again, if you're not sure what's happening, these are the steps. Make sure you understand why those steps are there and what's happening. Lastly, these questions again say check. So our check is going to look like this. We'll start with the equation. Equals, negative 4 equals 3 plus k over 7. And now we're going to stick in our k value, which we calculated, into there. 3 plus negative 49 over 7. So negative 4 equals 3 plus negative 7. It checks, right? 3 plus negative 7 is negative 4, so this must be correct. All right, the assignment will be on the blog. You guys, good luck.